Alchemy is real. Scientists have successfully created gold from lead. Near collisions occurred inside the Large Hadron Collider, a 27-kilometer circumference machine buried 175 meters underground on the French-Swiss border. This device stripped 3 protons from lead atoms, instantly producing billions of gold atoms. Has the dream and hope of alchemists to get rich finally become reality? Hello and welcome back. Alchemy is an ancient system of knowledge combining science, philosophy, and mysticism that emerged in antiquity and flourished in Europe, the Middle East, and Asia during the Middle Ages. The ultimate goal of alchemists, both East and West, was to discover the philosopher's stone and to transform base metals like lead into gold. In fact, the term alchemy comes from a Chinese-Vietnamese transliteration. In this context, Gai means refining or heating substances, while Kim refers to gold or metal. Therefore, Gai Kim means metal, refining, or gold making. But why lead? Why did medieval alchemists attempt to create gold from lead instead of another, more common metal at the time, such as iron or copper? The idea is that lead closely resembles gold. Both are dense, heavy, soft, malleable, and ductile. Many people consider alchemy to be a precursor to modern chemistry. Chemistry focuses on chemical reactions that change one substance into another. However, if you're familiar with chemistry, you know that chemical reactions only alter the bonds between atoms by rearranging electrons. These reactions occur outside the atomic nucleus and do not change the number of protons and neutrons within it. Meanwhile, it's the atomic nucleus, not the surrounding electron cloud, that determines the identity of an element. Gold is defined when its nucleus contains exactly 79 protons. Adding 1 proton turns it into mercury. Removing 1 makes it platinum. So, in principle, creating gold simply requires adjusting the number of protons in an atomic nucleus to 79. This is beyond the capability of TOP chemistry. In other words, right from the start, alchemists and chemistry in general lacked the ability to transmute elements, i.e., turn lead into gold. Nuclear physicists, however, are different. Since the 20th century, they've known that atoms aren't fixed and can be transformed from one element to another. Naturally, gold is produced in large quantities during extremely energetic astronomical events called supernova, when massive stars collapse under their own gravity, reaching temperatures and pressures so high that free neutrons are forced into lighter atoms like iron, nickel, and cobalt, transforming them into heavier elements such as gold, platinum, and uranium. These gold particles disperse throughout the universe, eventually accumulating on rocky planets like Earth. They are later mind-melted and forged into rings by humans. Alternatively, the gold in your ring might even come from collisions between neutron stars, the second densest objects in the universe. On Earth, gold also forms naturally through the radioactive decay of certain isotopes of mercury and platinum. For example, Mercury-195 has 80 protons and 115 neutrons. 80-115, 195. When it decays, 1 proton converts into a neutron, reducing the proton count from 80 to 79, forming gold 195 meters, which has a half-life of 30.5 seconds. You may have heard somewhere about the art of creating gold through nuclear bombardment. That technology does exist, and it's even considered quite old. In 1941, American physicist Glenn Seaborg and his team used a cyclotron particle accelerator to bombard mercury atoms with light particles such as protons or neutrons. Through this bombardment, the number of protons or neutrons in the mercury nuclei changed, producing various isotopes, including those of gold like O195 and O196. Both gold-195 and gold-196 are radioactive. A ring made of gold-196 would lose half its mass in just 6 days, decaying into platinum. There's also a small issue. The cost of synthesizing gold via this nuclear bombardment method is astronomically high. Roughly 1,000 billion times the market price. Forget it. Just forget it. In this nuclear bombardment process, the neutrons and protons must directly collide with the mercury nucleus. Because the nucleus is incredibly tiny, about 1/1,000,000th of a trillionth of a meter, the probability of a fast-moving neutron or proton hitting it head-on is extremely low to produce visible amounts of gold. Billions of trillions of particles need to be accelerated, resulting in billions of trillions of collisions under highly precise conditions, consuming vast amounts of energy and time. However, in this new method, direct collision isn't necessary. When two nuclei race through the particle accelerator at nearly the speed of light, sometimes they merely graze each other. Instead of a direct collision, the nuclei pass close enough to generate powerful electromagnetic forces disrupting their nuclear structures. This is a completely new method of elemental transformation using electromagnetic interactions, distinct from traditional nuclear bombardment. Electromagnetic force acts between charged particles due to their electric charge and motion. It's the force that binds electrons to the nucleus, maintaining atomic structure and serving as the foundation for all chemical and physical phenomena involving atoms. The electromagnetic field emitted by a lead nucleus is especially strong because it contains as many as 82 positively charged protons. When a lead nucleus moves through the LHC at 99.999% the speed of light, its electromagnetic field gets compressed perpendicular to its direction of motion, forming a thin disk of intense photon radiation. When lead nuclei pass very close to each other, these photons strongly interact with neighboring nuclei, exciting them into oscillation, causing them to emit 1, 2, or 3 protons or neutrons. This process is known as electromagnetic dissociation. In this dissociation process, no protons are ejected, the lead remains unchanged. If 1 proton is emitted, we obtain thallium. With 2 protons removed, we get mercury. And if 3 protons are stripped away from the lead nucleus, we end up with a nucleus containing 79 protons, in other words, gold. Using a device called a calorimeter to measure the number of protons and neutrons released, scientists determined that the LHC currently produces gold at a maximum rate of approximately 89,000 nuclei per second. Unfortunately, these gold nuclei, formed from near-collision interactions, possess extremely high energy and immediately crash into the walls of the accelerator tube, shattering into protons, neutrons, and other particles. In other words, the gold exists for only a fraction of a second. This method of element transformation via electromagnetic interaction was observed and measured during the second operational phase of the Large Hadron Collider, also known as Run 2, which lasted from 2015 to 2018. However, the results were only recently published this May, according to statistics. About 86 billion gold nuclei were created during the 4 RH experiments, with a total mass of around 29 picograms, or 0.29 billionths of a gram. Oh my God! Thanks to upgrades in Run 3, the amount of gold produced is nearly double compared to Run 2. Yet, the total quantity is still thousands of trillions of times smaller than what would be needed to make even a single ring. While the medieval alchemists' dream of turning lead into gold has technically become a reality, their hope of getting rich once again remains shattered. But if you really think about it, it's truly mind-blowing to realize that the medieval alchemists' dream of turning lead into gold could actually be achieved. All they were missing was a particle accelerator. What do you think about this groundbreaking scientific achievement? Please share your thoughts in the comments below. As always, don't forget to like and share this video if you found it informative. Subscribe to the channel HeckyFish and hit the bell icon to receive notifications for our latest videos.